Let's get into this pressure stuff a little bit, though. I just wanted to share this video. This is you've probably seen some stuff like this recently. There's been the shot of the rail train car go thunk suddenly because of a steam differential, the air pressure inside. If you make something really hot with steam, this is what they do with these 55-gallon drums we're about to watch. Actually, I'll just hit play. So this is a YouTube video. Atmospheric pressure crushes a 55-gallon steel drum. There's a young lady. She must be a student. I'm guessing that's the teacher guy, the bald dude manning the flame thing. They're standing outside. A bunch of kids are in the back too, kind of doing a good job being attendant. And whenever you're doing stuff with fire and steam, usually that's a little bit more interesting than your dumb old boring teacher and his chalkboard. So this girl's explaining stuff.
And the pressure inside of the can is going to be less than the pressure from the outside.
Pressure's inside is less than the pressure outside. 9.4 million views. This is 13 years ago. So what? Now she's closing it. She's
tight. Twist.
That's hot.
Twist it. Twist the hot can. It's a funny video.
That's fine.
So they got the cap on. Now there's steam inside this thing.
Ease.
They're going to pick it up with 2 sticks, which doesn't seem like the best way to do this. But
It sure is.
now they're moving the steel thing, which they've just been boiling water in, and they've sealed it up now. I would actually just expect the cap to come flying off, but they've moved it into a pool of water, like a little plastic kiddie pool. I think there's ice in there too, because at one point they like try to get the girl, or she starts putting ice on top of it, but she's like being kind of adorably like scared. I mean, you're dealing with some major shit right now in this video. Like I totally relate to like being hesitant.
I'm working a little bit.
Does that mean it didn't work?
No.
So now we're just waiting.
Throw some water on it. Yeah. Oh no, just grab the ice, Ewan, with your hands.
So put the ice on. So look at her. She's being scared. Kind of funny. She's tossing ice on top.
That is so wimpy.
Well, I'm scared that it's going to blow up in my hands.
Wait, look.
And then
Do it.
I think
Yeah.
it's getting concave.
okay, he's putting water, spraying it with a hose.
Oh, yeah.
It's great. It's insane. That's one atmospheric pressure. That's surface level. That's all of the pressure, all of the weight of all the air above you. And watching the kids in the back too, you can only see their legs the way the shot is right now, but it's really funny the way that they all just, everybody just goes boom. Here, one more time. Guys spraying water.
Oh, yeah.
It's so sudden. It's so sudden. It's amazing. You hear a little like, you tell it's kind of like going like a little bit of a creak, and then it just slams itself closed. Completely destroys that thing. So what happens is the steam inside is enough to resist the pressure. Before you put the cap on, the pressure is equalized. After you put the cap on, the steam is pushing out, and the steam is creating it's filling all the steam is highly activated molecules of H2O. There's a lot of energy in them because they've added it via heat. They've transferred some of that entropic difference, so they've increased the level of like measurable difference, basically. So it's hot, it's more agitated, and as you cool it with the ice, the bucket, the kiddie pool with ice cubes, and then spraying it with water, now the temperature starts coming down, and steam is going to then start to cool and reach its condensation point, at which point it converts from a gas into a liquid, which itself releases a little bit of energy. That's why evaporation works, to cool you off. But what happens inside the sealed thing is that all of a sudden the pressure inside goes from like a steam pressure to the steam becomes liquid, and now it is empty, basically. I don't know. I'm sure that it's measurable, but suddenly there's an immense differential that was not there because the steam converted into water, into condensation. And the strength of the outside pressure now just completely takes over, and just in an instant, it just shrivels up this little can, this 55-gallon drum into a mangled pile of 55-gallon drum metal. It's so powerful, and that's one. That's everywhere you are at every time. Your body is pushing against the pressure because you evolved in this layer. We can tolerate a little bit of a differences in pressure, but it's fucking crazy. And so pressure, it's a little bit tricky to get your head around. It's not the same as gravity, but it's caused by gravity. It's because it's the consequence of the Earth displacing, the concentration of mass, of which we call the Earth, pulling, distorting space in a uniform sort of sphere. It fluctuates a little bit based on where mass is. I mean, it's like there's always like little nuances around the edges, but all this distorted space causes mass to gather around this point in space, which then forms a planet, and then attracts different layers of materials. If you think of different materials as being an environment, like if you're 6 miles underground under a mountain and you're in solid granite, you're not going to survive that as a consciousness. It doesn't work. But you're still if you're just inside a granite chunk, you're inside a pressure. You're inside something that has a pressure, and you're in an environment. And then you go deeper, you get to the molten part of the Earth's core. The phase between the mantle, into the mantle, and then into the molten regions, and then the solid iron ball core. And there's some nuances to that as well. It's amazing. What the fuck am I trying to say? Oh, so this ball attracts. It's not that. It's actually different. The way that we understand gravity is a little confusing. But the ocean sticks to the orb, to the sphere. The gas above the ocean, our atmosphere, is just stuck to it because it's just pulled towards the thing, and there's an immense amount of weight, even though air is invisible. It's amazing that it's invisible. You ever just look around and be like, wow, I can't see it at all. Like you can see smoke because you're seeing particles of something else. You can see pollution because you're seeing particles of something else. But the air, this incredibly important and thing that we can't see, we should protect it. It's obviously critical for our but it piles up. So it's this huge pile. And the reason it works in one of the things that's kind of confusing about pressure is that you think it only works because it's being pulled downward by gravity. It's not that. The reason it goes in all directions is because while the originating kind of force is the fact that everything is being pulled towards the center of the Earth, the pressure works in all directions, including up and down and side. It's uniform in all directions because that attempted displacement is shoving molecules in all directions, no matter where it is, because of the weight of the entire region around you of pressure. So when you go into the ocean, it only takes 33 feet to reach, or water. Water is 8 pounds a gallon. So it only takes 33 feet of depth to reach another atmospheric pressure unit. So when you start counting 33, so 100 feet of ocean is over 3 atmospheric pressures. The Titanic submersible was down at like 13,000. It was like something close to 400 atmospheric pressures. And one way to think about it that I was trying to get my head around is lightning. Pressure. I need to look this up actually, so you feel free to correct me if you want to. But what causes thunder when lightning, which is a discharge of electricity from one positively charged side of a cloud to a negatively charged side of the cloud, or to the ground, which has a charge differential, which causes these gigantic sparks to, activate. And superheat the air around it, so that lightning displaces I don't know how thick lightning is actually, but it displaces a column of air around it. It activates the heat, and it immediately changes pressure really, really, really fast and really strong. And so I think either the lightning or the thunder comes from the push out and then now you've created a big wave, a sudden. So now the sound wave is traveling, but also I think it's both. When the lightning goes away, the electricity part of it, it collapses back. So it gets like this air sitting there minding its own business. It gets sheared open by the sudden presence of electricity, this charge. It gets pushed open really fast and then closed really fast. So it's just like your hands clapping is. I mean, it's like. So it opens up, it causes thunder, and then it closes really fast, which adds to the thunder. I think it's both. Either way, it's a consequence of the pressure of the air around it. It's a consequence of pressure differential. We use pressure to fly planes. I actually had a job briefly teaching science stuff to kids. It was this company. I don't want to say the name of the company, but it was like they sent out people who they hired based on personality. I mean, I come across pretty well with people when I try. Doing stand-up comedy. I'm fairly comfortable in these kinds of things. So I think it was a decent decision to hire me. The rate that they advertised was way fucking higher. The pay rate was way higher than what it turned out to be, because I actually completely hated it. But they teach you these like modules, and you go to like schools and you do presentations on science concepts, kind of like you're like a fun science teacher. I think I kind of could have seen myself getting into it if I'd gotten past the initial shock of how little paid it was and how kind of much I hated doing it. So I went out and I did one. It was I shadowed a little bit, and I did one with, and the module that I learned was about pressure. We learned about the Bernoulli effect, which is the what causes lift in an airplane, which is the reason that works is because you have the air that travels on top of the wing travels further than the air that travels below the wing. That's why the wing is sort of curved a little bit. And because the air on top travels further than the air at the bottom, even though they're going at the same speed, it creates a pressure differential that trends towards lift. And so that's what causes a wing to create lift. The force that lifts up the airplane is pressure, because the air, you're splitting the air into two different streams that have different pressures. There you go. And it flies planes, and it's pretty cool. And I mean, that's how wings function. It's pretty neat. I hated that. I hated doing that job. I hated it so much. I did it like once, and it was, I quit. I went and I quit like the very next day. It was horrible. For very little money. It was like I was getting like $13 an hour or something. It was awful. What the fuck am I trying to say? Oh, so the lightning comes from pressure. Then it closes, right? Basically, the reason I'm pointing at trying to get your head around that, I hope this is good podcasting, I have no idea, is that what the sub is and what those deep sea ones, the limiting factor in James Cameron's big green fishing lure, the exact same thing applies to those, but those were safely engineered. Those were properly engineered. That's what I was saying earlier too. That entire industry has never had this kind of disaster, because these guys who do these deep sea ocean stuff, but they've been doing shit since before the 60s. But there's this one vessel that traveled down in the 60s that was like so there's like, this is a fairly mature field, really. You're basically bringing your environment down to the bottom. And when you seal in 5 people in a tube, you're locking in surface pressure, which is what we need, which is what our bodies are acclimated for. We can like, deep sea divers can go down, swim down. You've seen those weirdos who like sink a big rope and then like just drop down next to the rope, and they have the huge fins, and they do insane stuff. I saw a thing about their lungs. Like, their lungs compress to the point they get down like 300 meters maybe, or feet. I don't know, whatever it is. It's like nutty stuff. Their lungs are like like 10% of their original size or something like that. So like they factor that into the way that they do those super deep, like free diving. Another type, this was not someone on, I think, James Cameron's crew of his gang of dudes that like help him with his stuff, does this trick with styrofoam cups where he draws a picture on it and like kind of writes like a little note, and he does like a pack of them, like 10 or something, and he puts it in a baggie some kind of baggie on the side of the thing. And after it goes down, it comes back up. Each little styrofoam cup, which is just a regular kind of coffee size, is now like a little cute little shot glass or smaller, because and the drawing is still intact. It looks fine, and they're kind of cute. They're kind of neat little mementos this guy makes for like their customers or whatever. What you're doing is, though, you're locking yourself into a surface pressure, and then you're challenging the earth by going down into these other pressures and crossing through these thresholds. You know, every 33 feet, it's another atmosphere. Every 33 feet, it's more. And so they're 370 atmospheres down. Essentially what that is, when there's a crack, it's not gravity. I don't want to be confusing about that, but it's like when we do stuff with physics, when we manipulate chemistry to create combustion or other ways of converting some kind of chemical reaction into mechanical energy to spin stuff. Almost every machine is just a way of spinning something in a way we want. It's like a car, obviously. And then we take that spinning and we can convert it into gears and convert it into different, it's an incredibly amazing thing humans do. We're just playing with like the very little edges of physics. When you fuck with pressure, though, at this level, you are visiting, like, I don't know how to describe it, but it's like you're going past the Balrog. It is on the order of like nuclear. I don't even know what framework I'm even trying to get at, but it is like deeper than, it's not a competition, but it is, if you're making a movie about it, it would be like 1,000 Balrogs. That makes no sense. It's like I don't know the word. I can only make a noise. It's this noise. That's the noise in the movie of it. It's, you know, that shot of the sun, and you just want to make someone feel something ominous, like you're Werner Herzog. It's just, it's like the deep rooted core. So for the briefest of moments, when what they basically did was freeze a lightning bolt, because they took surface pressure and they exposed it to 400 atmospheric pressures or whatever the number was. So they created that suspension. So it's almost as if, say, the lightning struck, it opened up the vacuum, and then they didn't let the vacuum close. So it's like if you could press pause on lightning right after the lightning disappears, it wants to break. So that's why the spheres resist the pressure. The one James Cameron was in, and these other, like, those things are the same thing. We've got this little bubble that has to be incredibly strong, or the takes over and just basically destroys everything all at once. It pushes in, but also as soon as the pressure is released, and I don't know if this is the case, that when you crack that protective sleeve, when you unpause the lightning bolt, basically, now it's far stronger, 400x, probably some kind of other multiplier. But you hit the unpause button because you didn't engineer your vessel to hold up against it. And I don't know if this is true, but it might be that, just like the little coffee cup, right, that was exposed, because it actually goes down gradually, right? It's not just suddenly exposed. So it probably would rip it apart if it was suddenly exposed. I wonder, because I really want to learn about the physics of implosion. Is it like every cell in the body basically goes through what that coffee cup did? Does your body just kind of go like it just like rips itself apart in a millisecond? It is faster. Like, one thing I kept seeing is like it's way faster than the brain can perceive. Like we can perceive things in like 100 milliseconds, or like pretty fast, but nothing. I don't know what the numbers are, but like this shit all happens in like 1 millisecond. It's like less than 1 millisecond. It's so fast. So it's actually a pretty good way to die. I would take it. I think if I knew that going in, it'd probably be pretty scary. That's how I was going to die. But just being surprised, there's no surprise. just one moment, maybe like this tin thing, like this can here, there's like, what's that noise? And then then there's nothing. Then it's just so it's over. But it's also not uniformly applied, and there's also a ton of other factors that immediately go into play, like the coldness of the ocean too, and so like the other parts getting in the way of this explode. It's not nothing. Things in the real world are usually not as precise as they are in a clean computer simulation or something like that, or you have to model all those other factors. So it's plausible that there might have been some human remains in the forms of, you know, a piece here and there, if it wasn't because the sudden implosion wouldn't have been necessarily uniformly applied to every single part inside. But the concept that it's like pausing a lightning bolt, basically, and now you've got this pressure thing ready to blow, and then suddenly it releases, and it's just like this can here, except it's 400 atmospheres. I know I keep saying the same thing, but yeah, that's rough, man. That's some, because obviously the other stuff, the hull itself is going to break and collide with the people, and also collide with what's inside. But by the time the hull materials are moving inwards, it's moving inwards from every direction. But I don't even know if by that point the people's bodies are even articulated anymore, or are non, like, I think they're completely articulated into bits by that point. But it happens within like less than a minute. So like, and also I've seen stuff, and I think this has been debunked, or I'm not sure what the science is, but that the speed of all that raises the temperature to like the surface of the sun. I saw people leaving comments about that. That seems a little bit. By the way, the surface of the sun, like there's parts of the Earth that, like, the surface of the sun's not as hot as you think. It's really hot. It's much hotter in the core of the sun. The corona outside the surface of the sun is actually hotter than the inside of the surface, like right on the surface. And there really is no surface. It's these gigantic boiling cells. Basically, it's like huge globs of corn that reach down and deep into the sun that are convecting. They're shifting up and down. The sort of hydrogen shell on the outside of the sun. But yeah, I don't know. I'm just trying to wrap my head around what that must be. Not for the humans to experience it. The alternative story where they lose contact and they can't get up and they have to slowly die of starvation, or not starvation, of suffocate, you know, slowly run out of oxygen. That's far more horrifying than a catastrophic break. That's like where the human stuff really comes into play. The sound for that, like, so we've got this sound. We've got. The sound for that would be human noises. You know, like Event Horizon. You've seen Event Horizon, where they have that weird blood orgy and they get all crazy and violent and stuff. It's so horrifying to think about that version of the story. The suffocation narrative. But yeah, man, it's fucking crazy. It's just nuts. I hope I've explained that. I don't know. Let's watch this can blow up one more time. I don't think I did it. I feel like I could have. Yeah, I really want some kind of science and some sort of study. And I think there probably will be something, but like just hearing, oh, it happened so fast, that's not satisfying to me. Like, I want to know stage after step after step after step, because it was even though we're talking about the very fastest thing, kind of, there is a sequence of events that unfolds in that moment, and a lot of stuff happening simultaneously too. But what does even the concept of simultaneity even mean? But it's every bit. It's way more powerful than like an explosion. It's not our brains can kind of conceptualize an outward explosion, aside from the fact that we see movies and we know what war weapons do. We see explosions our whole lives. But you could just slap a puddle of water. We've all jumped in a little puddle of water, or, you know, you see, you know, drop a glass on the ground and it goes out in all different directions. It explodes. It's not that hard, but the understanding implosion is weird. It's not just a small crumple. It's like the physics of the pressure force this thing, and then there's the blowback. So it's going to push a whole bunch of shit out afterwards. So anyway, we should be dropping shit down to the bottom of the ocean, watching it blow up. That would be the fucking tourist business I would start. Come down with me. All right. I'll yell about my beard falling out a little bit on the way down. Talk about socialism. Talk about how much your boss sucks. Then when we get down to the bottom, we've already lowered the fireworks show. We've already dropped down a couple of poorly designed things that are going to blow up when we tell it to. I'll even let you push the button, and we get to watch cool explosions. And then like just bubbles go up and debris rains around, and yeah. But yeah, that's kind of what I settled on this past week. Is I've been thinking about it a good bit. It's just like what it's a little like pausing lightning and then just waiting for the deep, like it's I don't know. Like the relentlessness of physics. There's no like hesitation. There's only correction. It's like this was a case where we hubristically challenged Earth to prove itself, challenged the universe. By we I mean a human in the kind of generic, a human person, Stockton Rush. Dangerous ideology of being against safety. So crazy. And obviously lost the challenge, but like the notion of being that deep in the ocean and having the ocean, the weight of all that water, it's not just the water straight above you, it's all the water around that's pushing all the water everywhere, because it's all interconnected in terms of pressure equalizing. The equalization of pressure is why things sit stable. So you introduce an unstable element into a system that was minding its own business. Not that there's any intention to it or anything, but it's so deep. It's so much more deeper than any god. It's rooted in that, like the core. I feel like Joe Rogan would get his brain melted by this kind of conversation if I could get him on my show, as if that's my goal. I'd actually meet Joe Rogan once at the Young Turks. Yeah, that was, yeah, I shook his hand. He's short. I mean, I'm over 6 feet, not bragging or anything, but yeah. Anyway, okay, we'll watch this blow up one more time. I'm just starting to say the same thing over and over again.
Yeah. Oh, it's
Top
do
way
it.
down?
Do it.
I think
Yeah.
it's getting
Oh.
concave.
Water on the can.
Oh yeah. Oh, I hear it.
Boom. That's such a perfect response. I love the screams immediately followed by yeah. Ah! Nice. So yeah, this is a science experiment that I predict will be making a comeback in science classrooms. Well, hopefully outside the school. Probably don't do that indoors.